Hello and welcome to Coding from the Car, this time a little more from the car than usual. I'm on vacation this week and I've been traveling and getting to know the great state of North Carolina. And let me tell you, it's been great getting fresh air and time alone. But I've also had a lot of time to think. For example, what the f*** is up with async await? I've never bothered to learn asynchronous programming because I'm just someone who's a programmer for fun. But all the fresh air got to my head and here we are. Now to understand asynchronous programming, you must know about synchronous programming, which everyone kind of already does, even if they don't know it. Let's use a cup of coffee for example. You grab your coffee, put it in the coffee maker, close the lid, then grab a cup, get the stupid f***ing wrapper off of it, fill the cup with water, add the water to the coffee machine, place your cup, close the lid again, and let it brew. Grab your cup, set it on the counter, and get your creamer. Add stuff to the coffee so it doesn't taste like coffee anymore. Stir. One task after another until it's done. That's what synchronous programming is. And there's nothing wrong with this method. In fact, C# programs are synchronous by default. But doesn't it feel weird to stare at a cup of coffee being brewed? Why not use that time more efficiently? Or at least not be stuck here staring. That's where async programming comes in. Imagine how much time you would save if you grabbed the creamer while the coffee brewed. Okay, probably not a lot of time. How long do you think it would take to count to 250 million? Days? Weeks? Years? Well, my computer can do it in about 1,204 milliseconds or about 1.2 seconds. All jokes aside, you can check this yourself too. Start a console application, then make sure you are using system.diagnostics. This allows us to use the stopwatch class. You can create a new stopwatch by setting a stopwatch variable equal to stopwatch.startNew. Now write a for loop that increments all the way to 250 million like I did here. Afterwards, create an int variable and set it equal to 0. Have the for loop increment this variable to 250 million as well. This way you have proof that the loop actually went all the way to 250 million. Lastly, stop the stopwatch by calling stop on your stopwatch variable after the loop. Console.writeLine both the variable that you incremented inside the loop and the elapsed milliseconds by using your stopwatch variable .elapsed milliseconds. My code looked like this. Run your code and now we have the benchmark that we need to beat. So now, how do we get your computer to count to 250 million faster? Don't think too hard, it's an irrelevant question. The point is, async programming helps you to tell your program to multitask. I think we could all agree it would be faster to count to 50 million versus 250 million. So to be faster, we just have to bump it down to 50 million and copy and paste it for a total like 5 loops, right? Well, no, because it still works one task after another. What we need to do is hire some people to do the counting for us. When you make an async function and you tell it to run a couple tasks, it pretty much does all the hiring and managing of the employees for you. Got to retrieve something from the web? Well, that job is for the network card. No sense in me waiting around for the network card to do its job. Oh, you need to do math or count to 50 million 5 times? Well, that job is for the CPU logical processors, and they work off threads. And as an async function, I can create threads when necessary. Don't believe me? Here's what Microsoft says. I/O bound code is awaited, so it basically frees the thread while the I/O is doing work, and CPU code like math is started on a different background thread. Quick tip, anytime you are learning anything from a hack of a YouTuber like me, afterwards go and read the Microsoft docs for the same thing. This way you can start to understand official docs without having to have a 4-year computer science degree. Okay, so now our programming can run faster if we split the work, but that's not all. Imagine this, you boot up Chrome to go grab the latest download of Adobe Photoshop, and as soon as you hit download, your browser locks up and you are stuck. Or maybe you have programmed a task and it takes so long that it freezes the window. This can be demonstrated using WPF. This is a program I built to count 2.5 billion using WPF to show the effects of synchronous versus asynchronous programming, using the same for loop method I used before. It's hard to tell from context here, but when I click the button, the computer counts away in the background. Meanwhile, the application freezes up. Do this yourself and you'll see the button has frozen color, the Windows controls, such as close, minimize, and maximize, won't respond, and you can't move the window. Until the counting has stopped, at least. As I said before, your program will just do this by default. Normally it's not a problem because you don't normally count to such high numbers, but there are instances where you need to increase performance or user experience. So now we know why we need to use it. How do we write it? Well, we do this in WPF for two reasons. Console applications are no fun, but the second reason is it's much easier to do and more effective in a GUI window setting. So set up a WPF app like this one. You'll be greeted with this lovely window. And if you go to the toolbox at the side, you'll see this button control. You can drag 3 of these into the window and place them wherever you want. Then resize them to be a little longer. Next, where it says content in the code, rename it to these 3 things. The window should look something like this. Next, go to the CS file and get rid of all the extra stuff we don't need. It should go from this to this. This isn't necessary, it's an OCD thing for me. Next, we need to set up a few global variables. The first is a list of tasks, which is done like so. Next is a list of functions, which looks like this. And for those who don't know, an action is a function. Next, we need some global double variables. You can use an int variable, but at the time, I thought I might go past 2 billion. For now, create 6 doubles. One of these is for the final tally, the other 5 will be used so each individual loop can maintain its own scope. More on this later. Next, we need to make our 5 loops like we did before. Remember, we are trying to prove that we can count to 250 million faster than we did in the baseline test. We'll nest each of these loops inside of a function, with each function containing a local variable that will be incremented. Each loop will go to 50 million because we are splitting the work between 5 threads, and at the end of the loop, we will set the result of the incrementation equal to one of our global variables. Copy and paste this one function for a total of 5. Then change the variable inside so each function maintains its own scope without stepping on the toes of the other functions. We do this because even though each function will run independently from each other with async, the global variables are still on a synchronous scope. And if all these functions simultaneously try to tally towards a 250 million total, then it's kind of like trying to count with someone else shouting out numbers. This is why we call this async await, not just async. We'll talk about this later. So with that out of the way, you should have 5 functions that look like this. And as stated, each one points to its own personal global variable. Now that you have your loops inside functions, we need to add each function to the function list we created earlier. To do this, create another function that adds each function to the list by calling your function list.add for each loop, like I did here. Next, we need a function to run each of the loops. I know it seems monotonous, but we need this function list for parallel async functionality. You'll see later. For now, you can look at this as if we're trying to maintain clean code, which is bullshit, but hey, who cares? To run each function, use a for each loop on the function list, calling the function in the loop like I did here. Lastly, for the setup, make sure you call the function that adds the loops to a list inside the main window constructor. Now to get the ball counting, I guess. Go back to the XAML file and give all the buttons name like George or Tim, or maybe something sensible like I did here. Now with your button selected, go to the Properties tab, click the lightning bolt, then double-click here. Do this for each button. This will add a function to the CS file. When the button is clicked, this function is called. As you can imagine, we will be demonstrating the effects of synchronous, asynchronous, and asynchronous parallel programming in the topic's respective button. For the synchronous button, it's the same as our baseline from before. Zero out the count, console.writeLine the count beforehand, create a stopwatch, call the function that runs over all the loop functions, stop the stopwatch, Then we need to make one last function to add the total from all 5 loops together, because if you remember, the loops have their own personal global variable, and we have to have the final total global variable. I didn't have to do it this way, but hey, what's one more function? Now call that function we just created, then console.writeline the results, both final count and elapsed milliseconds. Now run the app. Click the synchronous loops button, and the console will display the results. And just like before, right around 1.2 seconds. Each time you do it, it will vary depending on how your CPU feels in that moment. For the async loops button, copy and paste everything from the previous button except the function that runs the loops. Then in betwixt your start and stop, type await task.run, and inside the parentheses, it takes an action parameter, which we learned is just a different name for a function. So we put our loops function as a parameter. We'll get to why there is an error here in a minute, but for now we have some new info to unpack. So let's look at this bit of code. Firstly, a task is a class that inherits an action. There are a few ways to use tasks, but I won't get into it in this video. For now, just know what's required for async functions. Secondly, run, even though it sounds obvious, combines 2 lines of code that you would normally have to write, which usually looks something like this. Thirdly, our function is missing parentheses. This is because you can either reference or call a function. Without the parentheses, it is a reference. Thirdly, await is not only the other half to our async puzzle, but also saves us a 3rd line of code, which is this. It's also the reason we have an error. The whole point of this is to use async functions, which, as you can see, our function is no different than a normal function, which is why we need to use async. And the error goes away because await requires an async function. So what does await do? Here's the doc snippet if you're interested, but basically it pauses the completion of the code inside of the async function until the specified tasks are complete. Can't have one without the other. Well, you can, it just won't work right. Now run your app, click the async loops button, and you'll see that nothing has changed, still 1.2 seconds. At least not as far as speed. Play around with the size of your loops and try to make it like around 10,000 milliseconds. Click the first button again and try to move the window and close the app while the loop is running. Felt laggy, right? This lag you feel is called a blocked thread. Now do the same with the second button. If you followed along without error, I'm guessing while the app was counting you were still able to move and close the app. Be creative. I've not put this into practice yet, but just imagine all the ways you can improve your performance. The last one is quick because there is only one change we need to make. Do everything you did for the last button except, instead of typing task.run, we are rewriting the for each we wrote inside the loops function. The only difference is we are adding each function to our task list inside the loop, and we are converting each to a task using task.run like we did before. Lastly, we need to await task.winAll and use our task list as a parameter. The only thing new here is task.winAll, which the gist is that is a separate task that completes when a parameter of a collection of tasks, i.e. our task list, are all complete. You could also alternatively write this section of code like this, but I think you see why we did it this way. Now for the final test, run the app, click the async parallel button, and 250 milliseconds compared to 1188 from before. That's almost 5 times the speed. I hope you realize the point here wasn't actually to count to 250 million. Substitute the counting for any function that could run in the background without affecting your app functionality, and you get the point. Anywho, let me know if I did an okay job in the comments. If not, sorry. At least I learned a lot. Use them girthy fingers to drop a like and subscribe if you want to. Okay, bye.